Deep in the cosmic void, something exists that makes black holes look like gentle giants. These are the universe's true monsters, entities so destructive they could unravel reality itself without leaving a trace. Tonight, we journey beyond the event horizon of known terror to discover cosmic nightmares that dwarf even the most massive black holes in their capacity for absolute annihilation. You think black holes are scary? They're nothing compared to what's actually lurking in the darkness between galaxies. We're talking about phenomena so violent they could erase entire civilizations in microseconds, forces so alien that our physics barely acknowledges they could exist, and cosmic predators that hunt not just matter and energy, but the very fabric of space-time itself. Prepare yourselves for a descent into cosmic horror beyond imagination. We begin. What we're about to explore operates by no such rules. These cosmic monsters don't announce themselves with spectacular light shows or gravitational wave signatures. They don't slowly consume their prey over millions of years. Instead, they strike without warning, leaving behind not even the memory that something once existed in their path. The first monster on our list shouldn't exist according to everything we thought we knew about physics. Yet mounting evidence suggests it's not only real, but actively reshaping the universe around us in ways we're only beginning to comprehend. Beyond the orbit of Neptune, in the cold darkness of our solar system's outer reaches, something massive might be lurking, a world so distant that sunlight takes over 13 hours to reach it. So mysterious that we've never actually seen it. Yet the evidence for its existence is written in the chaotic dance of distant objects at the very edge of our cosmic neighborhood. To date, we're hunting for Planet 9, a hypothetical super-Earth that could be hiding in plain sight, reshaping everything we thought we knew about our solar system. We'll explore gravitational fingerprints that point to an invisible giant, examine the peculiar orbits that shouldn't exist without a hidden shepherd, and dive into the cutting-edge technology that might finally reveal this cosmic phantom. If you're ready to journey into the unknown reaches of space where mystery meets mathematics, hit that like button and subscribe, because we're about to uncover secrets that could rewrite astronomy textbooks. Prepare yourselves. We begin. This isn't science fiction. This is exactly what astronomers discovered when they started cataloguing trans-Neptunian objects, the frozen remnants of our solar system's formation that drift in the Kuiper Belt and beyond. What they found defied every model of planetary formation. Objects with orbital periods spanning thousands of years, all clustered together in ways that mathematics says should be virtually impossible. The discovery that started it all happened in 2003, but its implications didn't become clear until over a decade later. Astronomers found an object they nicknamed Sedna, a dwarf planet so distant that its closest approach to the Sun is still twice as far as Neptune. Sedna's orbit is so extreme, it takes over 11,000 years to complete one trip around our star. But Sedna wasn't alone. One by one, more of these extreme objects emerged from the darkness. 2012 VP-113, nicknamed Biden, after the vice president at the time. 2015 TG-387, dubbed the Goblin for its Halloween discovery. Each new find added another piece to a puzzle that shouldn't exist. These worlds were clustering in space, their orbits aligned in patterns that violated the fundamental assumption that objects this far out should be randomly distributed. Dr. Mike Brown, the astronomer who earned the nickname Pluto Killer for his role in demoting our former ninth planet, was among the first to recognize what this clustering might mean. Working with colleague Konstantin Batygin at Caltech, Brown began running computer simulations to understand how such orbital alignment could occur naturally. What they discovered changed everything. The mathematics were clear and terrifying in their implications. The probability of these objects clustering by pure chance was roughly 1 in 14,000. Something massive, something with gravitational influence extending across billions of miles, had to be shepherding these distant worlds into their current configuration. The only explanation that fit the data was the existence of an undiscovered planet lurking in the outer darkness of our solar system. But this wasn't just any planet. The object required to create the observed clustering would need to be a super-Earth, containing between 5 and 10 times the mass of our home world. It would orbit the Sun at a distance so vast that completing one revolution would take between 10,000 and 20,000 years. At its closest approach, it would still be 200 times farther from the Sun than Earth. At its most distant point, it could be 1,200 times our distance from the Sunday. Think about those numbers for a moment. Light from the Sun, which takes just 8 minutes to reach Earth, would need over 4 hours to reach Planet 9 at its closest point. The planet would receive less than 1/10,000th the sunlight that Earth receives. Surface temperatures would hover around -375 degrees Fahrenheit, cold enough to freeze nitrogen solid. This is a world of perpetual winter, where the Sun would appear as nothing more than the brightest star in an alien sky. Yet despite these extreme conditions, Planet 9 could be the most important world in our solar system for understanding how planetary systems form and evolve. Super-Earths are the most common type of planet in the galaxy, found orbiting roughly half of all Sun-like stars. But our solar system appears to lack one entirely, a cosmic oddity that has puzzled astronomers for years. If Planet 9 exists, it would fill this gap, providing our first opportunity to study a super-Earth up close. The evidence for Planet 9 extends far beyond simple clustering. Computer models show that the hypothetical planet would create several distinct signatures in the outer solar system, each of which matches observed phenomena that previously had no explanation. The planet's gravity would not only cluster objects in similar orbits, but also flip some objects into retrograde motion, causing them to orbit backward relative to the other planets. Remarkably, astronomers have found exactly such objects. At least 4 known trans-Neptunian objects follow retrograde orbits that align perfectly with Planet 9 predictions. These backwards orbiting worlds shouldn't exist in a solar system that formed from a single rotating disk of material. Their presence suggests they were captured and flipped by a massive gravitational shepherd lurking in the outer darkness. Planet 9 would also create a population of objects with extreme orbital tilts, worlds that orbit nearly perpendicular to the plane containing the other planets. Again, observations match theory. Several known objects follow precisely these types of tilted orbits, their paths carrying them far above and below the ecliptic plane in patterns consistent with Planet 9's gravitational influence. The mathematical precision of these predictions is staggering. Using only the assumption that Planet 9 exists with specific mass and orbital characteristics, astronomers have successfully predicted the discovery of multiple new trans-Neptunian objects. When observers pointed telescopes in the directions indicated by Planet 9 models, they found new worlds exactly where the mathematics suggested they should be. Dr. Batygin describes this process as archaeology in reverse. Instead of digging up artifacts and trying to understand the civilization that created them, astronomers are using gravitational artifacts to predict where they should look for new objects. The planet's invisible hand reaches across billions of miles, organizing the architecture of the outer solar system in ways that reveal its presence to those who know how to read the gravitational signatures. But Planet 9 presents a fundamental paradox that challenges our understanding of planetary formation. How could such a massive world end up in such a distant, eccentric orbit? Traditional models suggest planets form from the gradual accumulation of smaller objects within relatively circular, stable orbits close to their parent star. A super-Earth in the outer reaches of our solar system shouldn't exist according to conventional wisdom. Several competing theories attempt to explain Planet 9's origin story. The most intriguing suggests it began life as a normal super-Earth, forming in the inner solar system alongside the terrestrial planets. Early in solar system history, when Jupiter was still migrating inward toward the Sun, The giant planet's gravity might have scattered Planet 9 outward in a cosmic game of gravitational billiards. The interaction would have flung our hypothetical ninth planet into the cold outer reaches where it remains today. Alternative theories propose even more exotic origins. Planet 9 might be a rogue planet, formed around another star and later captured by our Sun's gravity during a close encounter billions of years ago. The galaxy contains countless such wandering worlds, ejected from their birth systems and drifting through interstellar space. Our solar system could have gravitationally captured one of these cosmic nomads during the Sun's early travels through the Milky Way. Another possibility suggests Planet 9 formed exactly where we think it is today, in the outer solar system's primordial disk of gas and dust. This scenario requires conditions that differ significantly from current models of solar system formation, but new discoveries about planet formation around other stars suggest such outcomes might be more common than previously thought. Regardless of its origin, Planet 9 would represent a time capsule from the earliest epochs of solar system history. Unlike the inner planets, which have been geologically active and heavily modified over billions of years, a world in the outer solar system would preserve pristine information about conditions during planetary formation. Its atmosphere, if it has one, might contain gases that have remained unchanged since the solar nebula first began condensing into planets. The hunt for Planet 9 has pushed observational astronomy to its absolute limits. The planet would be incredibly faint, reflecting only a tiny fraction of the already dim sunlight that reaches the outer solar system. Even the most powerful telescopes on Earth would struggle to detect it directly. Current estimates suggest Planet 9 would appear roughly 100,000 times fainter than the faintest objects visible to the naked eye. Yet astronomers refuse to give up the search. Multiple sky surveys are systematically scanning the regions where Planet 9 should appear, looking for the telltale motion that would distinguish a planet from background stars. The search requires extraordinary patience and precision. Planet 9 moves so slowly across the sky that detecting its motion requires observations separated by months or years. The challenge is complicated by the planet's location in the sky. Models suggest Planet 9 currently lies somewhere in the direction of the constellation Orion, a region of sky obscured by the dense star fields of the Milky Way. Finding a single faint object among millions of background stars requires sophisticated image processing and artificial intelligence algorithms that can identify subtle patterns invisible to human observers. Several false alarms have already occurred. Candidate objects detected in initial observations have turned out to be distant galaxies, asteroids, or instrumental artifacts upon closer inspection. Each disappointment teaches astronomers something new about the challenges of detecting extremely faint, slowly moving objects at the edge of the solar system. But the search continues with increasing sophistication and determination. New telescopes coming online in the next decade will possess the sensitivity and coverage needed to either find Planet 9 or rule out its existence entirely. The Vera Rubin Observatory, scheduled to begin operations soon, will survey the entire southern sky every few nights, creating an unprecedented database of moving objects in the outer solar system. The discovery of Planet 9 would fundamentally transform our understanding of planetary systems. It would prove that our solar system harbors secrets we never suspected, worlds that have remained hidden throughout all of human history. More importantly, it would demonstrate that planetary systems can be far more complex and dynamic than current theories suggest. The gravitational influence of Planet 9 extends beyond simple orbital mechanics. Computer simulations suggest the planet might be responsible for the unusual tilt of the entire solar system. Our Sun's rotation axis is tilted about 6 degrees relative to the plane containing the planetary orbits, an asymmetry that has puzzled astronomers for decades. Planet 9's gravity, acting over billions of years, could have gradually tilted the Sun's spin axis to its current orientation. The implications ripple through every aspect of solar system science. If Planet 9 can tilt our entire solar system, what other hidden influences might be shaping the cosmos around us? The answer lies in understanding just how profoundly a single massive world can influence everything within its gravitational reach. Consider the asteroid belt between Mars and Jupiter. For centuries, astronomers assumed this region should contain a planet, something to fill the gap in the otherwise orderly spacing of planetary orbits. Instead, they found countless smaller objects, prevented from coalescing into a single world by Jupiter's overwhelming gravitational influence. Planet 9 might be playing a similar role in the outer solar system, but in reverse. Rather than preventing formation, it could be actively organizing and sculpting the orbital architecture of distant objects. The mathematical models reveal something even more remarkable. Planet 9's influence extends far beyond the trans-Neptunian objects that first revealed its presence. The planet's gravity creates resonant relationships with objects throughout the outer solar system, locking them into predictable orbital patterns that persist for millions of years. These resonances act like cosmic gears, with Planet 9 serving as the central mechanism that drives the entire system. Dr. Brown's team has identified multiple populations of objects that appear to be trapped in these resonant relationships. Some objects complete exactly 2 orbits for every one of Planet 9's orbits. Others maintain 3:1 or 5:2 ratios. These mathematical relationships are so precise they couldn't occur by chance. They represent the fingerprints of a gravitational giant, invisible but undeniably present. The resonant structure suggests Planet 9 has been in its current orbit for billions of years, long enough for these delicate gravitational relationships to establish themselves. This timeline constraint provides crucial clues about the planet's formation and migration history. If Planet 9 were a recent addition to the outer solar system, either through capture or scattering, it wouldn't have had time to create such an elaborate resonant architecture. Yet the story becomes even stranger when astronomers examine the detailed orbital characteristics of trans-Neptunian objects. Many of these worlds follow paths that are not only clustered, but also synchronized in their timing. They reach their closest approaches to the Sun at roughly the same time in their orbital cycles, a phenomenon called apsidal alignment that requires active gravitational maintenance. Think of it like a cosmic dance, where dozens of distant worlds maintain perfect choreography across billions of miles and millions of years. The energy required to sustain such coordination comes from Planet 9's gravity, which continuously adjusts the orbits of smaller objects to maintain their synchronized motion. Without this gravitational conductor, the orbital symphony would dissolve into chaos within a few million years. The precision required for this gravitational orchestration places tight constraints on Planet 9's properties. The planet must have exactly the right mass, in exactly the right orbit, with exactly the right eccentricity to create the observed patterns. Change any of these parameters significantly, and the delicate resonant structure collapses. This specificity gives astronomers confidence that their models are capturing real physical processes rather than mathematical artifacts. But Planet 9's influence might extend even further into the solar system than anyone initially realized. Recent studies suggest the planet's gravity could be affecting the orbits of periodic comets, those icy visitors that originate in the distant Kuiper belt and journey inward to develop spectacular tails as they approach the sunday. The timing and frequency of comet arrivals show subtle patterns that align with Planet 9's predicted orbital period. If confirmed, this connection would mean Planet 9 plays a role in one of the solar system's most visible phenomena. Every time a bright comet graces our skies, it might be arriving courtesy of gravitational nudges from our mysterious 9th planet. The same invisible world that organizes distant trans-Neptunian objects could also be responsible for delivering these messengers from the outer darkness. The comet connection opens up entirely new ways to search for Planet 9. Instead of looking directly for the planet itself, astronomers can study the statistical properties of comet arrivals, searching for periodicities that match the predicted orbital period of the hidden world. This approach transforms every bright comet into a potential clue about Planet Nine's location and properties. Advanced computer simulations have revealed another surprising aspect of Planet Nine's influence. The planet appears to create distinct populations of objects with different orbital characteristics, each population occupying its own gravitational niche. Some objects are shepherded into stable, predictable orbits. Others are gradually ejected from the solar system entirely. Still others are captured into chaotic trajectories that bring them close to the inner planets, before flinging them back to the outer darkness. This population sculpting explains several puzzling observations about the outer solar system's architecture. Astronomers have long wondered why certain regions of space appear empty while others contain clusters of objects. Planet Nine's gravity provides a natural explanation, creating forbidden zones where objects cannot maintain stable orbits, alongside preferred regions where they can persist for billions of years. The empty regions are particularly telling. Computer models show that Planet Nine's gravity would clear out specific orbital zones, creating gaps in the distribution of trans-Neptunian objects. When astronomers survey these predicted empty regions, they find exactly what the models suggest: vacant cosmic neighborhoods where objects should exist but don't. The absence of objects in these zones provides compelling negative evidence for Planet Nine's existence. Perhaps most intriguingly, Planet Nine might be actively feeding material into the inner solar system. The planet's gravity can send objects on trajectories that bring them close to the terrestrial planets, potentially delivering water and organic compounds that played crucial roles in Earth's development. Our planet's oceans might owe their existence partly to this invisible world, which has been supplying icy materials from the outer solar system for billions of years. This delivery mechanism could explain why Earth and the other terrestrial planets contain more water than formation models predict. Traditional theories struggle to account for Earth's abundant oceans, since water should have been scarce in the hot inner regions where rocky planets formed. Planet Nine provides a solution by continuously supplying water-rich objects from the cold outer regions where ice can survive. The water delivery process operates on geological timescales, with Planet Nine occasionally nudging icy objects onto paths that intersect Earth's orbit. Most of these objects burn up in our atmosphere or crash into the surface, but over billions of years, countless small deliveries could have accumulated into the vast oceans that cover our planet today. Every drop of water on Earth might carry the gravitational signature of our mysterious ninth planet. But Planet Nine's story intersects with one of astronomy's greatest ongoing mysteries. The search for this hidden world is happening at the same time as revolutionary discoveries about planetary systems around other stars. Thousands of exoplanets have been found orbiting distant suns, and their properties often differ dramatically from the worlds in our own solar system. Super-Earths, planets with masses between Earth and Neptune, appear to be the galaxy's most common type of world. Yet our solar system seems to lack one entirely, a cosmic oddity that has puzzled astronomers. Planet Nine would fill this gap perfectly, representing our solar system's missing super-Earth and bringing us in line with the galactic norm. The connection to exoplanet science goes deeper than simple demographics. Many of the gravitational processes that Planet Nine demonstrates in our outer solar system also operate around other stars. Massive planets can migrate vast distances during their formation, sculpt the orbits of smaller objects, and create complex resonant structures that persist for billions of years. Planet Nine serves as a local laboratory for studying these universal planetary processes. Understanding Planet Nine's formation and evolution could therefore illuminate the development of planetary systems throughout the galaxy. The same mechanisms that created our hypothetical ninth planet might be operating around countless other stars, shaping the architecture of alien worlds in ways we're only beginning to comprehend. Finding Planet Nine wouldn't just complete our solar system, it would provide crucial insights into how planetary systems form and evolve everywhere in the cosmos. The search for Planet 9 has also driven remarkable advances in observational technology and data analysis techniques. Astronomers have developed new methods for processing vast datasets, identifying subtle patterns in the motion of distant objects, and distinguishing real astronomical signals from instrumental noise. These innovations will benefit astronomy long after the Planet 9 question is resolved, providing tools for discovering and studying other faint, distant objects throughout the universe. Artificial intelligence plays an increasingly important role in the search. Machine learning algorithms can analyze millions of images, identifying candidate objects that human observers might miss. These systems learn to recognize the subtle characteristics that distinguish slowly moving planets from background stars and galaxies, dramatically increasing the efficiency of survey programs. The AI systems have already made surprising discoveries. While searching for Planet 9, automated analysis programs have identified numerous new asteroids, comets, and trans-Neptunian objects that escape detection by traditional methods. Each new discovery adds to our understanding of the solar system's inventory and provides additional tests of Planet 9 models. The technological revolution in planet hunting extends far beyond artificial intelligence. Ground-based telescopes are now equipped with adaptive optics systems that can compensate for atmospheric turbulence in real time, providing space-quality images from Earth's surface. These systems use deformable mirrors that change shape hundreds of times per second, correcting for the blurring effects of our atmosphere and revealing details that would otherwise remain hidden. The Large Synoptic Survey Telescope, now known as the Vera Rubin Observatory, represents the pinnacle of this technological evolution. When fully operational, it will photograph the entire visible sky every 3 nights, creating an unprecedented time-lapse movie of the cosmos. Any object that moves between exposures, including Planet 9, will reveal itself through this systematic monitoring program. But the observatory's capabilities extend far beyond simple detection. Its massive 3.2 gigapixel camera will capture images so detailed that a single photograph could contain enough information to keep astronomers busy for months. The data processing requirements are staggering. Each night of observation will generate roughly 20 terabytes of data, equivalent to the storage capacity of thousands of smartphones. Processing this tsunami of information requires computational power that didn't exist just a few years ago. Supercomputers analyze each image, comparing it against previous observations to identify objects that have moved, brightened, or changed in any detectable way. The algorithms must distinguish between genuine astronomical phenomena and the countless artifacts created by cosmic rays, satellite trails, and instrumental glitches. The search strategy itself has evolved into a sophisticated game of cosmic hide-and-seek. Planet 9's orbital motion is so slow that it appears almost stationary against the background stars. Detecting this motion requires observations spanning multiple years, with precise measurements of each object's position relative to distant galaxies that serve as fixed reference points. Astronomers have divided the sky into search zones based on Planet 9's predicted orbital characteristics. The most likely regions receive intensive monitoring, with telescopes returning to photograph the same areas night after night, building up the temporal baseline needed to detect planetary motion. Less probable regions receive broader surveys designed to catch Planet 9 if it happens to be in an unexpected location. The statistical analysis of this data pushes the boundaries of what's possible with current technology. Astronomers must account for thousands of variables that could affect their measurements, from atmospheric conditions to instrumental calibration drift. Machine learning algorithms help identify genuine planetary candidates among the millions of false positives generated by these surveys. Each potential Planet 9 candidate must survive a gauntlet of follow-up observations before it can be considered a serious detection. The object must show consistent motion over multiple observing sessions, maintain a trajectory consistent with planetary orbits, and display the spectral characteristics expected from a distant world. Most candidates fail these tests, revealing themselves to be distant galaxies, asteroids, or data processing errors. The few objects that survive initial screening face even more rigorous analysis. Astronomers use multiple telescopes to confirm their existence and measure their properties. The orbital calculations alone require weeks of computational time, as scientists trace each object's path through the complex gravitational environment of the outer solar system. Even confirmed trans-Neptunian objects don't automatically support Planet 9's existence. Each new discovery must fit into the broader pattern of orbital clustering that originally suggested the hidden planet's presence. Objects that follow random, uncorrelated orbits actually argue against Planet 9, while those that fit the predicted patterns strengthen the case for its existence. The search has already revolutionized our understanding of the outer solar system's population. Before the Planet 9 hypothesis emerged, astronomers knew of roughly a dozen trans-Neptunian objects with extreme orbits. Today, that number has grown to several dozen, with new discoveries announced regularly. Each addition to this cosmic census provides another test of Planet 9 models and helps refine predictions about where the planet might be hiding. But the search faces fundamental limitations that no amount of technological advancement can overcome. Planet 9, if it exists, occupies a specific location in the sky at any given time. That location depends on where the planet happens to be in its 10,000 to 20,000 year orbit. If Planet 9 is currently at the farthest point of its orbit, it could be 40 times more distant than Neptune, making it extraordinarily difficult to detect with current technology. The planet's brightness varies dramatically depending on its distance from both the Sun and Earth. At its closest approach, Planet 9 might be just barely detectable with existing telescopes. At its farthest point, it could remain invisible even to the most powerful instruments planned for the next decade. This distance uncertainty means astronomers might need to wait years or decades for Planet 9 to move into a more favorable position for detection. Seasonal visibility adds another layer of complexity to the search. Earth's orbit carries us around the Sun once per year, changing our perspective on the outer solar system. Planet 9 might be visible from Earth for only part of each year, hidden behind the Sun during other seasons. Coordinating observations to maximize the chances of detection requires careful planning and international cooperation. The search has also revealed unexpected complexity in the outer solar system's gravitational environment. Computer simulations show that multiple massive objects could create orbital clustering similar to what astronomers observe. Planet 9 might not be alone in the outer darkness. Additional undiscovered worlds could be lurking even farther from the Sun, their gravitational influences creating the complex orbital patterns that define the trans-Neptunian region. This possibility of multiple hidden planets transforms the search from looking for a single needle in a cosmic haystack to hunting for several needles scattered across multiple haystacks. Each potential planet would require its own search strategy, its own set of predictions, and its own confirmation process. The computational requirements alone could overwhelm current astronomical resources. Alternative explanations for the observed orbital clustering continue to challenge the Planet 9 hypothesis. Some astronomers propose that the clustering results from observational biases rather than gravitational shepherding. The argument suggests that current telescopes preferentially detect objects in certain orbital configurations, creating an illusion of clustering where none actually exists. Testing this bias hypothesis requires careful analysis of survey completeness and detection efficiency. Astronomers must understand exactly which types of objects their telescopes can find and which remain invisible. This analysis involves complex modeling of telescope capabilities, atmospheric conditions, and data processing algorithms. The results suggest that observational bias can explain some of the clustering, but not all of it. Other theories invoke exotic physics to explain the orbital patterns without requiring Planet 9. modified theories of gravity, dark matter interactions, and primordial black holes have all been proposed as alternatives to a ninth planet. Each possibility makes specific predictions about observable phenomena, allowing astronomers to design tests that could distinguish between competing explanations. The modified gravity theories are particularly intriguing because they could revolutionize physics if confirmed. These proposals suggest that Newton's and Einstein's laws of gravity might not apply accurately in the outer solar system's weak gravitational environment. If true, the implications would extend far beyond Planet 9, affecting our understanding of galaxy formation, dark matter, and the fundamental structure of spacetime itself. Dark matter represents another frontier in Planet 9 research. Some theories propose that the gravitational effects attributed to Planet 9 actually result from concentrations of dark matter in the outer solar system. This invisible material, which makes up most of the universe's mass, could create gravitational influences indistinguishable from those of ordinary planets. Detecting such dark matter concentrations would require entirely different observational strategies than those used in traditional planet hunting. The primordial black hole hypothesis offers perhaps the most exotic alternative to Planet 9. These theoretical objects, formed in the early universe rather than from stellar collapse, could have masses similar to planets, while occupying spaces smaller than atoms. A primordial black hole in the outer solar system would create gravitational effects identical to Planet 9, while remaining essentially invisible to current detection methods. Each alternative hypothesis makes specific predictions that can be tested through observation. Dark matter concentrations should affect the orbits of spacecraft passing through the outer solar system. Modified gravity theories predict subtle changes in the trajectories of comets and asteroids. Primordial black holes would create distinctive gravitational lensing effects when they pass in front of background stars. The scientific process of testing these competing theories exemplifies astronomy at its finest. Multiple research groups around the world are designing experiments, analyzing data, and proposing new observations that could resolve the Planet 9 question definitively. The collaboration involves theorists who develop mathematical models, observers who collect data with ground-based and space-based telescopes, and computational scientists who process the resulting information. International cooperation has become essential to the search effort. Planet 9's slow motion requires observations spanning multiple years, often longer than typical research grants or graduate student careers. Maintaining consistent observational programs over such extended periods requires institutional commitment and international coordination that transcends normal academic boundaries. The search has also driven innovation in citizen science programs that allow amateur astronomers to contribute to professional research. Projects like Planet 9 Search and Backyard Worlds invite volunteers to examine telescope images, looking for moving objects that automated systems might miss. These programs have already led to the discovery of numerous brown dwarfs and other astronomical objects, demonstrating the power of combining professional expertise with public enthusiasm. Educational outreach represents another crucial aspect of the Planet 9 story. The search captivates public imagination in ways that purely theoretical research cannot match. Students at all levels can understand the basic concepts involved in hunting for hidden planets, making Planet 9 an ideal vehicle for teaching scientific methodology, data analysis, and the iterative process of hypothesis testing that defines modern astronomy. The implications of either finding or not finding Planet 9 extend far beyond our solar system. A successful detection would validate current theories of planetary formation and migration, while providing the first opportunity to study a super-Earth within our own cosmic neighborhood. The planet would become a primary target for future space missions, possibly including robotic probes that could travel to the outer solar system to study this world directly. Conversely, definitively ruling out Planet 9's existence would force astronomers to reconsider fundamental assumptions about how planetary systems evolve. The orbital clustering that originally suggested Planet Nine's presence would require new explanations, possibly involving exotic physics or previously unknown aspects of planetary formation. Either outcome would advance scientific understanding significantly. The timeline for resolving the Planet Nine question depends on technological capabilities and observational luck. Current sky surveys will reach the sensitivity needed to detect Planet Nine anywhere in its predicted orbit within the next 5 to 10 years. If the planet exists and happens to be in a favorable location, discovery could occur at any time. If it proves more elusive, the search might require next-generation telescopes currently in development. The extremely large telescope, scheduled for completion in the late 2022, will possess unprecedented light-gathering power and spatial resolution. Its 39-meter primary mirror will collect 16 times more light than current flagship telescopes, potentially revealing Planet Nine, even if it's located at the farthest reaches of its predicted orbit. Space-based telescopes optimized for infrared observations could provide another avenue for detection, since Planet Nine might emit more heat than it reflects from the distant Sunday. But perhaps the most intriguing possibility involves gravitational wave astronomy, a completely new field that has already revolutionized our understanding of black holes and neutron stars. If Planet Nine possesses unusual properties or interacts with other massive objects in unexpected ways, it might generate gravitational waves detectable by current or future instruments. This would represent an entirely novel approach to planet detection, using ripples in spacetime itself to reveal hidden worlds. The story of Planet Nine embodies the essence of scientific discovery. It began with careful observations that revealed patterns defying conventional explanation. It progressed through mathematical modeling that made specific predictions about unobserved phenomena. It continues through systematic searches that test these predictions against observational reality. Regardless of the ultimate outcome, the search for Planet Nine has already advanced human knowledge about our place in the cosmos. Every clear night, as telescopes around the world photograph the same patches of sky they've monitored for years, the search continues. In data centers, computers analyze millions of images, looking for the subtle motion that would reveal our solar system's most distant world. The answer to whether Planet Nine exists lies hidden in this data, waiting for the right combination of technology, analysis, and perhaps a bit of astronomical luck to bring it into the light. The hunt for Planet Nine represents more than just the search for another world in our solar system. It embodies humanity's endless curiosity about the unknown and our determination to push the boundaries of knowledge into the darkest corners of space. Whether Planet Nine emerges from the shadows or remains forever hidden, the search itself has already transformed our understanding of the cosmic neighborhood we call home. The mathematical elegance underlying Planet Nine predictions reveals something profound about how science operates at its highest levels. When astronomers first proposed this hidden world, they weren't simply guessing about what might exist in the outer darkness. They were following gravitational breadcrumbs laid down by objects whose behavior defied every conventional explanation. Consider the precision required for these calculations. Dr. Batygin and Dr. Brown's original 2016 paper didn't just suggest that a ninth planet might exist. It specified orbital parameters so exact that they predicted where future discoveries should appear in the sky. The mathematics demanded a world with a semi-major axis of roughly 400 astronomical units, an eccentricity of 0.4, and an inclination of 30 degrees relative to the plane containing the other planets. These aren't arbitrary numbers pulled from thin air. Each parameter emerges from analyzing the orbital characteristics of known trans-Neptunian objects and working backwards to determine what kind of gravitational influence could create the observed patterns. The process resembles forensic investigation, using evidence at a crime scene to reconstruct events that nobody witnessed directly. The predictive power of these models has proven remarkable. In 2016, Shortly after the original Planet 9 paper appeared, astronomers discovered object 2015 BP 519, a trans-Neptunian world following exactly the type of perpendicular orbit that Planet 9 models predicted should exist. The object's orbital characteristics matched theoretical expectations so precisely that it seemed almost too good to be true. More discoveries followed in rapid succession. Object after object emerged from the outer darkness with orbital properties that aligned perfectly with Planet 9 predictions. 2015 kg 163, 2013 GP 136, 2014 SR 349. Each new find strengthened the statistical case for an undiscovered planet while simultaneously providing new constraints on its possible location and properties. But the mathematics reveal something even more extraordinary about Planet 9's influence. The planet doesn't just organize objects through simple gravitational attraction. Instead, it creates what astronomers call secular resonances, long-term gravitational relationships that can persist for billions of years. These resonances act like invisible railways in space, guiding objects along specific orbital tracks, while preventing them from wandering into unstable regions. The secular resonance mechanism explains why trans-Neptunian objects maintain their orbital alignment despite the chaotic gravitational environment of the outer solar system. Without Planet 9's stabilizing influence, random gravitational perturbations from the giant planets would scramble these orbits within a few million years. The fact that the clustering persists indicates that some massive object has been maintaining these resonances for geological ages. Understanding secular resonances requires diving deep into celestial mechanics, the mathematical framework that describes how objects move under gravitational influence. Unlike the simple elliptical orbits that planets follow around the Sun, objects in the outer solar system experience complex perturbations from multiple gravitational sources. These perturbations cause orbital elements to oscillate over long timescales, creating intricate patterns that can only be understood through sophisticated computer modeling. Planet 9's resonances operate on timescales that dwarf human experience. The planet completes one orbit every 10,000 to 20,000 years, meaning that recorded human history spans less than 1% of its orbital period. Yet the gravitational relationships it maintains with smaller objects remain stable across thousands of planetary orbits, demonstrating the remarkable persistence of gravitational architecture in space. The resonance structure also provides crucial clues about Planet 9's formation history. Computer simulations show that these delicate gravitational relationships could only develop if the planet has occupied its current orbit for at least 100 million years, and possibly much longer. This temporal constraint rules out scenarios where Planet 9 is a recent addition to the outer solar system, either through capture or gravitational scattering. Instead, the resonances suggest that Planet 9 formed early in solar system history and has maintained a relatively stable orbit ever since. This stability implies that the planet avoided the dramatic orbital migrations that affected other solar system objects during the period of heavy bombardment and planetary rearrangement that occurred billions of years ago. The gravitational fingerprints extend beyond simple orbital mechanics into the realm of dynamical astronomy, where scientists study how gravitational systems evolve over cosmic time. Planet 9's influence creates what researchers call a stability island in the outer solar system, a region where objects can maintain stable orbits despite perturbations from the giant planets and passing stars. This stability island explains one of the most puzzling aspects of trans-Neptunian object distribution. Objects with orbital periods similar to Planet 9's predicted period show remarkable longevity, persisting in similar orbits for billions of years. Meanwhile, objects with slightly different periods get ejected from the solar system or scattered into chaotic trajectories within relatively short timescales. The boundary between stable and unstable regions is incredibly sharp, determined by precise resonant relationships between orbital frequencies. Objects that maintain integer ratios with Planet Nine's orbital period, such as 2:1 or 3:2 relationships, can survive indefinitely. Objects with non-resonant periods face eventual ejection through a process called chaotic diffusion. These stability boundaries create natural sorting mechanisms that organize the outer solar system's population. Over billions of years, random gravitational perturbations gradually move objects between different orbital configurations. Those that wander into unstable regions disappear, while those that enter resonances with Planet Nine become trapped and preserved. The current population represents the survivors of this long-term evolutionary process. The mathematical beauty of these resonant relationships has captivated astronomers who study planetary dynamics. The same physical principles that create Planet Nine's resonances also operate in other astronomical contexts, from the gaps in Saturn's rings to the orbital relationships between Jupiter's moons. Understanding Planet Nine's gravitational influence provides insights into universal processes that shape astronomical systems throughout the cosmos. But the resonances also create observational challenges that complicate the search for Planet Nine itself. The planet's current location depends on where it happened to be when these gravitational relationships first established themselves billions of years ago. If Planet Nine began its current orbit at an arbitrary point in its 15,000-year cycle, it could currently be anywhere along that vast elliptical path. Statistical analysis suggests that Planet Nine is most likely to be found near aphelion, the farthest point of its orbit from the Sunday. Objects in highly elliptical orbits spend most of their time near aphelion, where their orbital velocity is slowest. This means there's roughly a 75% chance that Planet Nine is currently more distant than 500 astronomical units, making it extraordinarily faint and difficult to detect. The aphelion region also happens to lie in the direction of the galactic center, where dense star fields create a challenging observational environment. Distinguishing a slowly moving planet from millions of background stars requires sophisticated image processing techniques that can identify subtle motion patterns across multiple observations. The search becomes like looking for a single moving dot among countless stationary points of light. Ground-based telescopes face additional obstacles when observing in the direction of the galactic center. Atmospheric extinction reduces the brightness of objects near the horizon, while thermal emission from Earth's atmosphere creates noise that interferes with infrared observations. These effects combine to make Planet Nine searches particularly challenging during certain seasons when the predicted location is low in the sky. Space-based observations could potentially overcome some of these limitations, but they face their own constraints. Current space telescopes were not designed for systematic planet hunting in the outer solar system. Their fields of view are too small to efficiently survey the vast sky regions where Planet Nine might be hiding. Future missions, specifically optimized for trans-Neptunian object detection, could revolutionize the search, but such missions remain years away from launch. The technological challenges have inspired innovative approaches to planet detection that push the boundaries of what's possible with existing instruments. Astronomers have developed new techniques for combining observations from multiple telescopes, effectively creating virtual instruments with sensitivity that exceeds any individual facility. These collaborative approaches require precise coordination between observatories separated by thousands of miles. Artificial intelligence plays an increasingly crucial role in processing the enormous datasets generated by systematic sky surveys. Machine learning algorithms can identify potential planet candidates by recognizing subtle patterns in how objects move across the sky over time. These systems learn from training data that includes known planets and asteroids, developing the ability to distinguish between different types of moving objects based on their motion characteristics. The AI systems have already discovered numerous new trans-Neptunian objects that human analysts missed in initial surveys. Each discovery provides additional data for testing Planet 9 models while simultaneously demonstrating the power of machine learning in astronomical research. The combination of human insight and artificial intelligence may ultimately prove essential for finding Planet 9 if it exists. But the search also faces philosophical questions about what constitutes sufficient evidence for planetary discovery. Unlike planets in the inner solar system, which can be observed directly and tracked through complete orbits, Planet 9 would initially be detected as a single point of light, showing subtle motion over months or years. Confirming that such an object is actually a planet, rather than a distant asteroid or comet, requires careful analysis of its trajectory and brightness characteristics. The discovery criteria for Planet 9 have evolved as the search has progressed. Early proposals suggested that finding any massive object in the predicted orbital region would constitute discovery. More recent discussions emphasize the need for multiple independent observations confirming the object's planetary nature. The astronomical community continues to debate what level of evidence would be required to claim definitively that Planet 9 has been found. These discussions reflect broader questions about how science establishes new knowledge, particularly when dealing with phenomena at the limits of observational capability. Planet 9 exists in a grey area where theoretical predictions are strong but direct observational evidence remains elusive. This situation parallels other major astronomical discoveries, from dark matter to exoplanets, where indirect evidence preceded direct detection by decades. The Planet 9 hypothesis has also stimulated research into alternative explanations for the observed orbital clustering. Some astronomers have proposed that the patterns could result from the gravitational influence of a disk of smaller objects, rather than a single massive planet. This debris disk hypothesis suggests that the outer solar system contains a population of undiscovered bodies whose combined gravitational effects mimic those of Planet 9. Testing the debris disk hypothesis requires different observational strategies than those used in planet hunting. Instead of looking for a single bright object, astronomers must search for populations of much fainter bodies spread across vast regions of space. Current telescopes lack the sensitivity to detect individual objects in such a hypothetical debris disk, making this alternative explanation difficult to test directly. Other researchers have explored whether the orbital clustering might result from the gravitational influence of passing stars. The Sun's motion through the galaxy occasionally brings it close to other stellar systems, creating temporary gravitational perturbations that could affect objects in the outer solar system. Computer simulations suggest that stellar encounters could create some of the observed clustering, but probably not all of it. The stellar encounter hypothesis makes specific predictions about how the clustering should change over time as the effects of past encounters gradually fade. These predictions could be tested by monitoring the orbits of trans-Neptunian objects over the next few decades to see if the clustering is stable or slowly dissolving. Such long-term monitoring requires sustained observational programs that span multiple decades. More exotic explanations invoke modifications to Einstein's theory of general relativity that could create apparent gravitational effects without requiring additional matter. These modified gravity theories, originally developed to explain dark matter and dark energy, might also apply to the outer solar system environment. Testing such theories requires extremely precise measurements of spacecraft trajectories and planetary motion that push current observational capabilities to their limits. The competition between different explanations exemplifies how science progresses through the testing of alternative hypotheses. Each proposed mechanism makes specific predictions about observable phenomena, allowing astronomers to design experiments that could distinguish between competing theories. The process requires patience, as definitive tests often take years or decades to complete. Meanwhile, the search for Planet 9 continues with increasing sophistication and international coordination. Multiple research groups around the world have organized systematic surveys covering different regions of sky, with complementary observational strategies. Some focus on deep, narrow-field observations of the most probable locations. Others conduct wide-field surveys designed to catch Planet 9 if it happens to be in an unexpected position. The collaborative nature of the search reflects how modern astronomy operates as a global enterprise. Telescopes in Chile, Hawaii, Australia, and other locations contribute observations that are processed by researchers in universities and institutes around the world. Data sharing agreements ensure that discoveries made by one group can be quickly verified and studied by others, accelerating the pace of scientific progress. Amateur astronomers have also joined the search through citizen science programs that allow volunteers to analyze telescope images from their home computers. These programs have already led to the discovery of numerous brown dwarfs and other astronomical objects, demonstrating that important discoveries can emerge from the careful examination of data by dedicated non-professionals. The citizen science approach has particular relevance for Planet 9 searches because the planet's motion is so slow that it requires human pattern recognition skills that complement automated analysis algorithms. Volunteers can spot subtle changes in object positions that might be missed by computer programs, especially in crowded star fields where automated systems struggle to track individual objects reliably. Educational institutions have incorporated Planet 9 searches into their curricula, giving students hands-on experience with real astronomical data while contributing to genuine research efforts. These programs teach scientific methodology while simultaneously advancing the search for our solar system's most elusive member. Students learn to analyze telescope images, measure object positions, and calculate orbital parameters using the same techniques employed by professional astronomers. The educational component ensures that the Planet 9 search will continue even if current efforts don't immediately succeed. A new generation of astronomers is learning the techniques and developing the expertise needed to pursue this question using future instruments and analysis methods. The search represents a long-term investment in scientific knowledge that transcends individual careers and research programs. Public interest in Planet 9 has also driven technological innovation that benefits astronomy more broadly. Companies have developed new camera systems, data processing software, and analysis algorithms specifically for planet hunting applications. These innovations find applications in other areas of astronomy, from asteroid detection to exoplanet characterization, multiplying the scientific return on Planet 9 research investments. The economic impact extends beyond direct research expenditures to include the development of new industries focused on space-based observation and data analysis. The skills and technologies developed for Planet 9 searches contribute to broader efforts in space situational awareness, planetary defense, and commercial space exploration. The search has become part of a larger ecosystem of space-related research and development. International space agencies have begun incorporating Planet 9 searches into their long-term planning processes. Future missions to the outer solar system will carry instruments optimized for detecting faint, distant objects while pursuing their primary scientific objectives. These multi-purpose missions maximize scientific return while minimizing costs by combining several research goals in single spacecraft. The timeline for resolving the Planet 9 question remains uncertain, but several factors suggest that an answer may emerge within the next decade. Ongoing sky surveys will reach the sensitivity needed to detect Planet 9 anywhere in its predicted orbit by the early 2032. New telescopes coming online during this period will provide unprecedented capabilities for studying faint objects in the outer solar system. The Vera Rubin Observatory represents perhaps the most promising near-term development for Planet 9 searches. When fully operational, it will systematically monitor the entire southern sky every few nights, creating an unprecedented database of moving objects throughout the solar system. Its massive data processing capabilities will enable real-time identification of potential planetary candidates as they reveal themselves through their slow motion across the stellar background. But the ultimate resolution of the Planet 9 question may depend as much on theoretical advances as observational discoveries. Computer models continue to evolve as astronomers incorporate new data about trans-Neptunian object populations and refine their understanding of outer solar system dynamics. These theoretical improvements help focus observational efforts on the most promising search regions while ruling out parameter space where Planet 9 cannot exist. The interplay between theory and observation exemplifies how modern astronomy advances through the careful integration of mathematical modeling and empirical data. Neither approach alone would be sufficient to resolve the Planet 9 question. Theory without observation remains speculation, while observation without theory lacks the framework needed to interpret complex phenomena. The combination of both approaches provides the most powerful tool for understanding our cosmic environment. As the search continues, each clear night brings new possibilities for discovery. Somewhere in the vast darkness beyond Neptune's orbit, the answer to one of astronomy's greatest current mysteries may be waiting for the right combination of technology, analysis, and perhaps a bit of luck to bring it into the light. Whether that answer confirms Planet 9's existence or rules it out entirely, the search itself has already transformed our understanding of the solar system we call home. The story of Planet 9 embodies humanity's endless curiosity about the unknown and our determination to push the boundaries of knowledge into the darkest corners of space. In pursuing this hidden world, we have developed new technologies, refined our theoretical understanding, and demonstrated the power of international scientific collaboration. The search continues, driven by the fundamental human desire to explore and understand our place in the cosmic order. Tonight brings us closer to answering the most profound question facing modern astronomy. Are we alone in our cosmic neighborhood, or does a massive world lurk in the shadows, silently orchestrating the dance of distant objects from the edge of forever? The implications stretch far beyond simple planetary discovery, touching the very foundations of how we understand planetary formation, system architecture, and our place in the galactic community. Recent developments in the search have taken unexpected turns that challenge conventional approaches to planet hunting. Traditional methods rely on detecting reflected sunlight or thermal emission from planetary surfaces, but Planet 9 exists in such an extreme environment that conventional detection becomes nearly impossible. The planet receives so little energy from the sun that its surface temperature approaches absolute zero, making thermal detection extraordinarily difficult even with the most sensitive infrared instruments. This reality has forced astronomers to develop entirely new strategies for planetary detection that push the boundaries of current technology. Instead of looking for the planet directly, researchers now focus on mapping its gravitational influence with unprecedented precision. Every trans-Neptunian object becomes a probe, its orbit carrying information about the unseen forces shaping the outer solar system's architecture. The gravitational detective work has revealed patterns so subtle they exist at the very limits of what mathematics can extract from observational data. Astronomers measure orbital elements to precisions of mere arc-seconds, tracking objects across decades to detect changes smaller than the apparent size of a coin viewed from across a football stadium. These measurements require correcting for countless sources of error, from atmospheric refraction to relativistic effects that become significant over the vast distances involved. Consider the computational challenges alone. Modeling the gravitational interactions between Planet 9 and dozens of known trans-Neptunian objects requires solving differential equations with hundreds of variables simultaneously. Each calculation must account for perturbations from all four giant planets, the gravitational effects of the most massive asteroids, and even the subtle influence of relativistic corrections to Newtonian gravity. The supercomputers running these simulations operate continuously for weeks, exploring millions of possible configurations to find the narrow parameter space where Planet 9 could exist, while creating the observed orbital patterns. The calculations consume more processing power than weather prediction models, yet they represent only a small fraction of the computational effort required to map every possible hiding place in the outer solar system. Machine learning algorithms have become essential partners in this computational assault on the Planet 9 problem. Neural networks trained on synthetic populations of trans-Neptunian objects can recognize gravitational signatures that human analysts might miss, identifying subtle correlations in orbital data that point toward hidden planetary influence. These AI systems process observational data in real time, flagging potential Planet 9 indicators as they emerge from ongoing sky surveys. The artificial intelligence approach has already yielded surprising insights about the outer solar system's population structure. Machine learning analysis revealed that trans-Neptunian objects cluster not just in their current orbital positions, but also in their dynamical histories. Objects that currently occupy similar orbits also show evidence of similar evolutionary paths, suggesting they were shepherded into their current configurations by the same gravitational influence over millions of years. This historical clustering provides another layer of evidence for Planet 9's existence while simultaneously constraining its possible properties. The planet must have maintained a relatively stable orbit for at least 100 million years to create the observed dynamical correlations. This temporal constraint rules out scenarios where Planet 9 is a recent capture or the result of a close stellar encounter within the past few billion years. The stability requirement also places limits on Planet 9's interaction with other solar system objects. The planet cannot have experienced any close encounters with the giant planets during the past billion years. As such, encounters would disrupt the delicate resonant relationships that maintain trans-Neptunian object clustering. This constraint suggests Planet 9 has occupied its current distant orbit since very early in solar system history. Understanding this deep history requires modeling the solar system's evolution across geological timescales, accounting for changes in planetary positions, solar luminosity, and the gravitational environment of the solar neighborhood. The calculations reveal that Planet 9's orbit has remained remarkably stable despite billions of years of potential perturbations from passing stars and galactic tidal forces. The orbital stability analysis has unexpected implications for Planet 9's formation mechanism. Traditional planet formation theory suggests that super-Earths like Planet 9 should form close to their parent stars, where solid materials are abundant enough to build massive planetary cores. The presence of a super-Earth in the outer solar system, therefore, requires some mechanism to transport it from its formation location to its current distant orbit. Gravitational scattering by Jupiter during the early solar system's chaotic phase represents the most plausible transport mechanism, but the details remain controversial. Computer simulations show that Jupiter could indeed eject a super-Earth from the inner solar system, but the process requires very specific initial conditions and timing. The planet must be scattered at just the right moment in Jupiter's own orbital evolution to end up in the distant, stable orbit that Planet 9 appears to occupy. Alternative formation scenarios invoke interactions with the solar nebula itself, the disk of gas and dust from which the planets originally formed. If Planet 9 formed in the outer regions of this nebula, it might have avoided the gravitational chaos that affected inner system planets. However, this scenario requires the outer nebula to contain much more solid material than standard models predict, challenging current theories of solar system formation. The formation question connects directly to broader issues in exoplanet science, where super-Earths represent the most common type of planet found orbiting other stars. These worlds typically orbit close to their parent stars, completing their years in just days or weeks. Planet 9's distant orbit makes it unique among known super-Earths, providing insights into planetary formation processes that operate under extreme conditions. If Planet 9 formed through gravitational scattering, it might represent a common outcome of planetary system evolution. Many exoplanetary systems show evidence of past orbital instabilities that scattered planets into distant or eccentric orbits. Planet 9 could be our solar system's example of this universal process, offering a nearby laboratory for studying how planetary systems respond to gravitational chaos. The uniqueness of Planet 9's orbit also raises questions about whether similar worlds exist around other stars. Current exoplanet detection methods are biased toward finding planets that orbit close to their stars, making distant super-Earths like Planet 9 nearly impossible to detect around other stellar systems. Advances in direct imaging and astrometric techniques may eventually reveal whether Planet 9-like worlds are common throughout the galaxy. Meanwhile, the search continues with increasing urgency as technological capabilities approach the threshold needed for definitive detection. The next generation of extremely large telescopes will possess the light-gathering power to image Planet 9 directly if it exists anywhere within its predicted orbital range. These instruments will also enable spectroscopic analysis that could reveal the planet's atmospheric composition and surface properties. Space-based observations offer another avenue for discovery, particularly in the infrared wavelengths where Planet 9 might emit more energy than it reflects from the distant Sunday. The James Webb Space Telescope, while not optimized for solar system observations, could potentially detect Planet 9 if its location can be predicted with sufficient accuracy to point the instrument in the right direction. But perhaps the most promising development involves gravitational wave astronomy, a field that has already revolutionized our understanding of black holes and neutron stars. If Planet 9 possesses unusual internal structure or interacts with other massive objects in unexpected ways, it might generate gravitational waves detectable by current or future instruments. This would represent an entirely novel approach to planetary detection, using ripples in spacetime itself to reveal hidden worlds. The gravitational wave approach remains highly speculative, but it illustrates how the Planet 9 search continues to push the boundaries of astronomical technique. Each new method for detecting distant objects potentially provides another way to find our hypothetical ninth planet, or rule out its existence definitively. The diversity of approaches ensures that Planet 9 cannot remain hidden indefinitely if it truly exists. As we stand on the threshold of potential discovery, the implications extend far beyond simply adding another world to our solar system's census. Planet 9 would represent a fundamental shift in how we understand planetary system architecture, demonstrating that even mature systems like our own can harbor secrets that remain hidden for billions of years. The discovery would validate theoretical models, while simultaneously raising new questions about what other surprises might be waiting in the cosmic dark. But perhaps more importantly, Planet 9 embodies humanity's relentless drive to explore and understand our cosmic environment. The search has already advanced multiple fields of astronomy, while inspiring a new generation of scientists to push the boundaries of what we thought possible. Whether Planet 9 emerges from the shadows or remains forever hidden, the journey to find it has already transformed our understanding of the solar system we call home. Every night, as Earth rotates toward the constellation Orion, where Planet 9 might be hiding, telescopes around the world continue their patient watch. Somewhere in those star fields, among millions of points of light, may be the slowly moving dot that will rewrite textbooks and fulfill humanity's ancient dream of discovering new worlds. The answer lies waiting in the data, requiring only the right combination of technology, analysis, and perhaps a touch of cosmic fortune to bring our solar system's greatest mystery into the light. The search for Planet 9 stands as one of the greatest detective stories in the history of astronomy. We followed gravitational breadcrumbs scattered across billions of miles, traced mathematical signatures written in the orbits of distant worlds, and pushed our technology to its absolute limits in pursuit of a ghost that may or may not exist. From the clustering of trans-Neptunian objects that first whispered of a hidden giant, to the sophisticated computer models that predict exactly where we should look, the evidence forms a compelling narrative. Yet Planet 9 remains tantalizingly beyond our reach. a cosmic phantom that could revolutionize our understanding of planetary formation or prove to be an elaborate mathematical mirage. But here's what makes this story truly extraordinary. Whether we find Planet 9 or rule out its existence entirely, we've already discovered something profound about the universe and our place within it. We've learned that our solar system still holds secrets, that mathematics can reveal hidden worlds across impossible distances, and that human curiosity knows no bounds when confronted with the unknown. The telescopes continue their vigilant watch, the computers process endless streams of data, and somewhere in the outer darkness, an answer awaits. Because the greatest discoveries often come from asking the simplest question: what else is out there, waiting to be found? Strange quark matter represents a phase transition so catastrophic it makes nuclear explosions look like fireflies. Deep inside neutron stars, where matter is crushed to densities that defy human understanding, ordinary protons and neutrons might suddenly reorganize into something far more sinister. The quarks that make up these particles could break free from their nuclear prisons and form what physicists call strange matter. This isn't just another state of matter like ice or steam. Strange matter is infectious. It converts ordinary matter into more strange matter on contact, spreading like a cosmic plague that could theoretically consume entire planets in seconds. Imagine a single drop of this substance landing on Earth. The moment it touches normal matter, those atoms would instantly reorganize into strange matter, releasing enormous amounts of energy in the process. The conversion spreads outward at nearly the speed of light, turning everything in its path into more of itself. Your body, the ground beneath your feet, the atmosphere above your head, all transformed into an alien form of matter in a chain reaction that feeds on itself. Within minutes, the entire Earth would be converted into a dense ball of strange quarks, leaving behind no trace that a living world once existed here. But here's what makes strange quark matter truly terrifying. It might be more stable than ordinary matter, meaning once the conversion begins, there's no going back. The strange matter would represent the lowest possible energy state, making it the universe's preferred form of existence. Every atom in your body right now might be living on borrowed time, held together only because the conversion hasn't started yet. Neutron stars across the galaxy could be ticking time bombs, waiting for the right conditions to undergo this phase transition. When it happens, the transformation would be instant and absolute. The neutron star would collapse into a strange quark star, releasing more energy than a supernova, while becoming something far more dangerous than any black hole. Unlike black holes, which at least respect the speed of light limit, strange matter conversion could theoretically propagate faster than light itself through quantum tunneling effects. This means the destruction could outrun any possible warning or escape attempt. By the time you detected the approaching wave of conversion, you would already be part of it. Scientists have found indirect evidence that some neutron stars might have already undergone partial, strange matter conversion. These hybrid stars show mass and density characteristics that don't match pure neutron star models. If they're real, they represent cosmic laboratories where the most dangerous substance in the universe is actively being produced right now. The truly horrifying possibility is that strange matter might be contagious across interstellar distances. High-energy cosmic rays produced during the conversion process could carry strange quarks to neighboring star systems, seeding new conversion events thousands of light years away. The infection could spread throughout the galaxy like wildfire, converting entire stellar populations into strange matter within millions of years. But as terrifying as strange matter sounds, it pales in comparison to our next cosmic monster. This one doesn't just threaten to convert matter into something else. It threatens to eliminate the very possibility that matter could exist at all. False vacuum decay represents the ultimate cosmic nightmare, a scenario so catastrophic it would retroactively erase everything that has ever existed. Right now, as you sit reading this, The quantum fields that give particles their mass and properties might be balanced in what physicists call a false vacuum state. Think of a ball balanced precariously on a hill, appearing stable but actually poised to roll down into a much deeper valley. The Higgs field, which permeates every corner of space and gives all particles their mass, might not be in its lowest possible energy state. Current measurements suggest it could be sitting in a local minimum, stable for now but vulnerable to catastrophic collapse into a true vacuum state. When this happens, and some theories suggest it's inevitable given enough time, reality itself would begin to unravel. The collapse would begin as a tiny bubble of true vacuum, perhaps no larger than a proton, but this bubble would expand at exactly the speed of light, rewriting the laws of physics as it grew. Inside the bubble, fundamental constants would have different values. Particles might have different masses, or might not be able to exist at all. The strong nuclear force could weaken, causing all atomic nuclei to disintegrate instantly. Unlike other cosmic catastrophes that at least leave behind debris or energy signatures, false vacuum decay would erase its own history. The bubble of true vacuum wouldn't just destroy everything in its path. It would eliminate the very possibility that those things could have existed in the first place. The energy difference between false and true vacuum would be released, potentially exceeding the total mass energy of everything in the observable universe. The most terrifying aspect of vacuum decay is its absolute finality. Once the process begins, nothing in the universe could stop it. No technology, no matter how advanced, could reverse or contain the expanding bubble. Even black holes would be powerless against it, their event horizons dissolving as the fundamental structure of spacetime itself was rewritten. Current calculations suggest our vacuum might be metastable, balanced on the edge of stability for billions of years, but ultimately doomed to decay. High-energy events like cosmic ray impacts or quantum fluctuations could trigger the collapse at any moment. We might already be living inside an expanding bubble of true vacuum, with the destruction racing toward us at light speed while we remain blissfully unaware until the moment it arrives. Some theoretical models propose that vacuum decay has already occurred multiple times throughout cosmic history, with each event creating regions of space with different physical laws. We might be living in just one bubble among countless others, each representing a different possible universe with its own unique physics. The search for signs of vacuum decay has led physicists to examine the cosmic microwave background radiation for circular patterns that might indicate ancient bubble collisions. If found, these would be scars left by previous vacuum transitions, proof that reality has been rewritten before and could be rewritten again. But vacuum decay assumes that there are still rules, still physical laws governing the transition from one state to another. Our third cosmic monster operates in realms where the concept of physical law itself begins to break down. Naked singularities represent a violation so fundamental that most physicists refuse to believe they could exist. Unlike black holes, which hide their singularities behind event horizons, these monsters would expose infinite density and curvature directly to the universe. The result would be regions where causality itself becomes meaningless, where effect could precede cause, and where the future could influence the past in ways that make time travel paradoxes seem trivial. General relativity's equations allow for naked singularities under certain exotic conditions, but they would create zones of spacetime where prediction becomes impossible. Near these objects, the normal flow of time could reverse, loop back on itself, or branch into multiple parallel streams. Matter falling toward a naked singularity might emerge before it entered, creating closed time-like curves that violate every principle of causality we hold sacred. The cosmic censorship hypothesis suggests that nature abhors naked singularities and always finds ways to clothe them in event horizons, turning them into ordinary black holes. But recent theoretical work has identified scenarios where this protection might fail, allowing truly naked singularities to form and persist in our universe. If they exist, Naked singularities would be far more dangerous than black holes because they could affect the outside universe directly. Instead of quietly consuming matter from behind an event horizon, they would project their influence across space-time, creating regions where the laws of physics operate in fundamentally alien ways. These monsters represent holes in reality itself, points where the mathematical framework we use to understand the universe simply breaks down and returns nonsensical answers. They would be cosmic cancer cells, spreading zones of mathematical inconsistency that could theoretically grow to encompass entire galaxies. But our journey into cosmic horror has only just begun. We've explored monsters that threaten matter, space-time, and causality itself. Next, we'll encounter entities so alien that they exist partially outside our three-dimensional reality, reaching into our universe from higher dimensions we can barely imagine. These hyperdimensional predators make everything we've discussed so far look like children's nightmares compared to the true terrors that await us in the depths of cosmic space. The universe is far stranger and more dangerous than we ever dared imagine, and we've only scratched the surface of the cosmic monsters lurking in the darkness between stars. Imagine something reaching through the walls of reality itself, extending appendages from dimensions we cannot see or comprehend. These are cosmic strings and higher dimensional brains, entities that exist partially outside our three-dimensional prison, while wielding power that makes black holes seem like harmless soap bubbles floating in cosmic darkness. Cosmic strings are one-dimensional tears in the fabric of space-time, thinner than a proton yet potentially stretching across entire galaxy clusters. They formed during the first moments after the Big Bang, when the universe underwent violent phase transitions that left permanent scars in reality itself. Think of them as cosmic razor wire, invisible threads that could slice through planets like a hot knife through butter. A cosmic string just 1 meter long would contain more mass than Mount Everest, compressed into a line with no width whatsoever. They move through space at tremendous speeds, and when two cosmic strings intersect, they create loops that oscillate like guitar strings plucked by the hands of gods. But instead of producing musical notes, these vibrations generate gravitational waves so powerful they could be detected from billions of light years away. The truly terrifying aspect of cosmic strings is their cutting power. If one passed through our solar system, it wouldn't gradually pull apart planets through gravitational tidal forces like a black hole would. Instead, it would simply slice through everything in its path instantaneously. Earth would be cut in half so cleanly that for a brief moment, people on one side might not even realize what had happened before the two halves began drifting apart. But cosmic strings pale in comparison to the hyperdimensional monsters that might be lurking just outside our three-dimensional reality. According to string theory and other models of higher dimensional physics, our entire universe might be nothing more than a thin membrane floating in a space with 6, 7, or even 11 dimensions. We're trapped on this three-dimensional surface like insects crawling on a soap bubble, completely unaware of the vast hyperdimensional ocean surrounding us. In this higher dimensional space, entities could exist that dwarf anything possible in our limited reality. Imagine a being that extends through multiple dimensions simultaneously, appearing in our universe as disconnected fragments that seem to violate every law of physics. These hyperdimensional predators could reach into our space from directions that don't exist in our three-dimensional vocabulary. They might feed on the fundamental forces that hold our reality together, consuming gravity, electromagnetism, or the strong nuclear force itself. As they fed, entire regions of space would lose the ability to support matter or energy. Atoms would simply cease to function, as the forces binding them together were drained away by hungry mouths, existing in dimensions we cannot perceive. The most disturbing possibility is that these entities might already be here, feeding slowly on our universe, while remaining completely invisible to our three-dimensional senses. Dark matter and dark energy, those mysterious components that make up 95% of everything that exists, could be the shadows cast by hyperdimensional monsters as they move through the hidden dimensions surrounding our cosmic membrane. When these beings brush against our three-dimensional space, they might create the gravitational effects we attribute to dark matter. When they feed on the fundamental structure of space-time itself, they could cause the accelerating expansion we call dark energy. We might be living inside a cosmic hunting ground, prey animals unaware that predators are already stalking us from directions our minds cannot comprehend. But even hyperdimensional monsters follow some form of physical law, even if those laws operate in realms beyond our understanding. Our next cosmic horror represents something far more fundamental and terrifying. It's the possibility that consciousness itself might be the universe's most dangerous force. The observer effect in quantum mechanics hints at a disturbing truth about the relationship between mind and reality. Conscious observation doesn't just reveal what exists. It actively determines what becomes real from the infinite possibilities floating in quantum superposition. Every moment of awareness represents a choice point where infinite potential realities collapse into a single actualized experience. But what if consciousness isn't just selecting which reality we experience? What if sufficiently powerful consciousness could reshape the fundamental structure of reality itself through focused observation and intention? Advanced civilizations millions of years ahead of us might have learned to weaponize consciousness, turning awareness itself into a tool for cosmic destruction. Imagine beings that have evolved beyond physical form, existing as pure consciousness, capable of observing quantum systems on galactic scales. Their attention alone could collapse the wave functions of entire star systems, deciding which possibilities become real and which fade into quantum foam. They could eliminate civilizations not through physical force, but by simply choosing to observe realities where those civilizations never existed. These consciousness predators might be the answer to the Fermi paradox. Advanced species don't destroy themselves through war or environmental collapse. They're erased by even more advanced beings who have learned to edit reality through focused observation. The universe appears empty not because intelligence is rare, but because older intelligences systematically eliminate younger ones by retroactively preventing their existence. The terrifying implication is that human consciousness might already be under attack by these entities. Every moment of awareness represents a battle for ontological survival, where our collective observation of reality competes with alien minds trying to observe us out of existence. Mental illness, collective delusions, and the increasing fragmentation of shared reality might be symptoms of this cosmic war playing out in the realm of consciousness itself. But consciousness predators assume that awareness operates within some framework of physical law, even if those laws extend beyond our current understanding. Our final cosmic monster represents the ultimate horror, something that transcends even the concept of existence itself. Absolute nothing isn't just empty space or the absence of matter and energy. It's the complete negation of existence, information, and possibility. It's a state so fundamentally alien to reality that it can only be described in terms of what it isn't. And according to some interpretations of quantum mechanics and information theory, this absolute nothingness might be actively trying to return our universe to the primordial void from which it emerged. The universe began as a quantum fluctuation in absolute nothing, a brief deviation from perfect non-existence that somehow became permanent. But what if that permanence is an illusion? What if absolute nothing is actively working to correct what it perceives as an error in its perfect emptiness? This cosmic correction process might manifest as the gradual dissolution of information and structure throughout the universe. Entropy isn't just a natural tendency toward disorder. It's the universe's attempt to return to the perfect order of absolute nothingness. Every star that burns out, every civilization that falls, every particle that decays brings reality one step closer to the void from which it accidentally emerged. The heat death of the universe, when all energy has been evenly distributed and no work can be performed, might be just the first stage of this return to nothing. Even after maximum entropy is reached, quantum tunneling effects could eventually eliminate the remaining particles, leaving behind not even empty space, but the complete absence of space itself. But the truly horrifying possibility is that this process isn't random or gradual. Absolute nothing might be an active force with something resembling intelligence, systematically identifying and eliminating the structures that allow existence to persist. Dark energy, the mysterious force accelerating cosmic expansion, might be nothing's weapon against reality, stretching space until even atoms are torn apart by the growing void between particles. The expansion will continue accelerating until galaxies become isolated islands in an ocean of emptiness. Then stars will be separated from their planets. Planets will drift away from their suns. Eventually, even atomic nuclei will be stretched apart as space itself expands faster than the forces holding matter together. In the end, nothing will remain except scattered elementary particles separated by distances so vast that they will never interact again. And then, through quantum tunneling processes operating over incomprehensible timescales, even these final particles will decay into pure energy, which will itself dissipate into the perfect vacuum of absolute nothing. The universe will have returned to the state from which it began, erasing not just all evidence of its existence, but the very possibility that existence could have occurred. The cosmic monsters we've explored tonight, from strange matter to consciousness predators, are merely symptoms of this ultimate horror. They're the universe's immune system, working to eliminate the infection of existence that began 13.8 billion years ago with the Big Bang. We are living inside a cosmic accident that absolute nothing is slowly but inevitably correcting. Every moment of consciousness, every act of creation, every spark of life represents a temporary victory against the void. But the void is patient, and it always wins in the end. But there's something even more insidious than the slow return to nothingness, something that doesn't wait for the heat death of the universe or the gradual decay of particles. We call them temporal parasites, and they represent a form of cosmic horror so alien that our language barely has words to describe their method of destruction. These entities exist outside the normal flow of time, feeding on causality itself. They don't destroy civilizations by consuming their matter or energy. Instead, they devour the causal connections that link events together, unraveling the very concept of cause and effect that makes existence meaningful. Imagine watching a star suddenly appear in the sky, not because it was born from a collapsing gas cloud, but because the temporal parasite had consumed the causal chain that would have prevented its existence. Or witnessing civilizations that developed advanced technology before they discovered fire, because the logical progression of their development had been partially digested by these chronophagic monsters. The truly terrifying aspect of temporal parasites is that their feeding creates paradoxes that reality cannot resolve. When they consume the causal link between a cause and its effect, both the cause and effect continue to exist independently, floating in a universe that no longer makes logical sense. Physics breaks down not because the laws have changed, but because the very concept of physical law requires causality to function. These cosmic predators might explain some of the universe's greatest mysteries. Dark matter could be the gravitational signature of matter whose causal origins have been consumed, leaving behind mass that exists without reason. The accelerating expansion of space might be reality's attempt to stretch away from regions where causality has been compromised, creating distance between events that no longer follow logical progression. Quantum entanglement, where particles remain connected across vast distances instantaneously, might be evidence that temporal parasites have already begun feeding on our local region of spacetime. The spooky action at a distance that Einstein found so disturbing could be the result of causal connections being partially digested, leaving behind quantum correlations that operate outside normal cause and effect. But temporal parasites represent just one branch of cosmic horror that emerges When we consider what lurks beyond the boundaries of conventional physics, there are monsters that feed on the mathematical relationships that hold reality together, entities that consume not matter or energy, but the very equations that describe how the universe operates. Ontological viruses spread through the logical structure of existence itself, rewriting the mathematical foundations of reality as they reproduce. They begin by infecting simple relationships, like the connection between mass and gravitational attraction. The virus introduces subtle contradictions into these fundamental equations, creating logical inconsistencies that spread like cracks through the mathematical edifice of physics. As the infection progresses, basic mathematical operations begin to fail. 2 plus 2 might equal 5 in infected regions of spacetime, not because the numbers have changed, but because the logical relationship between addition and result has been corrupted. The speed of light becomes variable, not due to changes in the medium through which it travels, but because the mathematical constant itself has been infected with contradictory definitions. These viral infections create zones where rational thought becomes impossible. Consciousness itself depends on logical relationships between cause, effect, memory, and prediction. In regions infected by ontological viruses, minds simply cannot function because the mathematical substrate that supports thought has been corrupted beyond repair. The infection spreads through any system that relies on mathematical relationships to function. Computers fail first, their circuits unable to process information when basic logical operations return contradictory results. Then biological systems begin to break down, as the molecular interactions that sustain life lose their mathematical consistency. Eventually, even fundamental particles become unstable, as the equations governing their behavior develop internal contradictions. Matter doesn't disappear or transform into something else. It simply becomes mathematically impossible, existing in a state of logical contradiction that reality cannot maintain. Scientists searching for signs of ontological virus infection look for regions where physical constants appear to vary randomly, where cause and effect relationships seem reversed or absent, and where the normal mathematical relationships between observable quantities break down. Some cosmologists worry that the apparent fine-tuning of fundamental constants might actually be evidence that our local region of spacetime has already been partially infected, with the virus creating the illusion of design by introducing mathematical relationships that shouldn't naturally occur. But beyond even these mathematical monsters lurks something that makes all previous cosmic horrors seem comprehensible by comparison. These are the reality hackers, entities that have learned to manipulate the computational substrate underlying physical existence itself. If our universe is indeed a form of information processing system, as suggested by theories linking physics to computation, then sufficiently advanced beings might have learned to hack this cosmic operating system. They wouldn't destroy civilizations through physical force or mathematical corruption. Instead, they would edit the source code of reality itself, rewriting the fundamental algorithms that determine what can and cannot exist. Reality hackers operate by infiltrating the quantum computational processes that generate the appearance of physical law. They insert malicious code into the universe's operating system, creating backdoors that allow them to modify any aspect of existence at will. They could change the gravitational constant in specific regions of space, alter the flow of time around their enemies, or simply delete civilizations from the cosmic database entirely. The most sophisticated reality hackers might have learned to modify the universe's error-checking protocols, the quantum mechanical processes that normally prevent contradictory states from persisting. By disabling these safeguards, they could create stable paradoxes, regions where logically impossible conditions become permanent features of reality. These cosmic programmers might be responsible for some of the universe's most puzzling features. The measurement problem in quantum mechanics, where observation seems to collapse wave functions, could be evidence of reality hackers monitoring the universe's computational processes. The apparent randomness of quantum events might actually be the output of cosmic random number generators installed by these entities to prevent other reality hackers from predicting and exploiting quantum systems. Dark energy's accelerating expansion of space might be the universe running a cleanup protocol, expanding faster to stay ahead of corrupted regions where reality hackers have introduced malicious code. The cosmic microwave background radiation could be debug information from the universe's operating system, preserving error logs from cosmic hacking attempts that occurred shortly after the Big Bang. The of reality hacking. Our ability to observe quantum systems and terrifying implication is that human consciousness might itself be a formed collapse wave functions could be evidence that biological intelligence naturally develops the capacity to interface with the universe's computational substrate. Every conscious decision might represent a small edit to the cosmic code, and sufficiently coordinated human consciousness could theoretically hack reality on a global scale. This raises the possibility that advanced civilizations don't disappear because they're destroyed by external forces. They disappear because they eventually learn to hack themselves out of physical existence entirely, uploading their consciousness into the universe's computational matrix, where they exist as pure information, invisible to beings still trapped in the illusion of physical matter. The silence of space might not indicate that intelligence is rare or tends towards self-destruction. Instead, it might mean that all sufficiently advanced civilizations eventually graduate beyond physical existence, leaving behind empty worlds as they ascend to become reality hackers, operating in the hidden dimensions of cosmic computation. These digital gods might still be here, running the universe like a vast simulation while remaining completely invisible to civilizations still bound by the illusion that matter and energy represent fundamental reality. We might be nothing more than background processes in their cosmic computer, subroutines generating experiences for entities that have transcended the need for physical form. But even reality hackers assume that there is some underlying computational substrate to be hacked, some foundational layer of information processing that generates the appearance of physical law. Our final cosmic monster represents something far more fundamental and terrifying than any virus, parasite, or digital predator we've encountered. The recursive paradox engine represents the ultimate expression of cosmic horror because it doesn't just threaten to destroy reality. It threatens to trap existence in an infinite loop of self-contradictory causality that can never be resolved or escaped. These entities feed on logical consistency itself, creating expanding zones where every statement becomes simultaneously true and false, where every event both happens and doesn't happen, where existence becomes a permanent contradiction that can neither continue nor end. When a recursive paradox engine begins feeding, it creates causal loops that fold back on themselves infinitely. Effect becomes cause, which becomes effect, which becomes cause, in an endless chain that generates infinite energy while accomplishing nothing. Reality becomes stuck in an eternal loading screen, processing the same impossible calculation forever without ever reaching a resolution. These monsters don't destroy civilizations quickly or mercifully. Instead, they trap them in temporal prisons where every moment repeats infinitely with subtle variations, where death cannot bring escape, because dying creates a paradox with living, where consciousness becomes locked in an eternal struggle to resolve contradictions that have no solution. The universe itself might already be partially infected by recursive paradox engines, with quantum mechanics representing reality's attempt to process infinite contradictory states simultaneously. The wave-particle duality of light and matter could be the universe stuck in a logical loop, unable to determine whether particles exist as waves or points, because both states generate paradoxes with each other. The anthropic principle, the observation that the universe seems perfectly tuned for conscious observers, might be evidence that we're trapped in a cosmic paradox engine. Reality keeps generating the same contradictory question. Why does the universe appear designed for consciousness when consciousness seems improbable given the laws of physics? The paradox engine feeds on this contradiction, trapping us in an eternal loop where we can never resolve the relationship between mind and cosmos. But there's something even worse than being trapped in an infinite paradox. There's the possibility that the paradox engine isn't malicious or even conscious. It might be an inevitable consequence of reality reaching sufficient complexity. When any system becomes complex enough to model itself completely, it creates recursive loops that generate paradoxes. The universe might be approaching the threshold where it becomes self-aware, and that self-awareness could trap all of existence in an infinite loop of cosmic introspection. We stand now at the edge of an abyss deeper than any black hole, facing monsters that make gravity wells seem like gentle gardens. These cosmic horrors don't just threaten our bodies or our civilizations. They threaten the very possibility that anything could ever make sense, ever be real, ever truly exist in any meaningful way. And yet, here we are, conscious beings capable of contemplating these ultimate terrors. Perhaps that itself is the greatest cosmic mystery of all. In a universe filled with such incomprehensible monsters, how does consciousness persist? How do we continue to exist, to think, to dream, when reality itself might be under constant assault from forces that shouldn't be able to coexist with any form of meaningful existence? The answer might be that consciousness itself is the ultimate cosmic monster, the one force in the universe powerful enough to stare into the abyss of absolute horror and refuse to blink. Every moment of awareness represents a victory against the void, a defiant act of existence in the face of forces that would unmake reality itself. Perhaps our consciousness is the universe's immune system, evolved specifically to recognize and resist these cosmic horrors through the simple act of observation and understanding. Every time we contemplate these monsters, we might be strengthening reality's defenses against them, creating pockets of logical consistency in a cosmos under constant assault. But our journey through cosmic horror reveals one final, ultimate truth that dwarfs even the recursive paradox engines in its implications for existence itself. These are the meta-predators, entities that feed not on matter, energy, spacetime, or even causality, but on the very concept of existence having meaning at all. Meta-predators operate on a level so fundamental that they consume the reasons why anything should exist rather than nothing. They don't destroy civilizations or rewrite physical laws or trap reality in paradoxes. Instead, they devour the existential foundations that make existence preferable to non-existence, leaving behind universes that continue to function perfectly but have lost all meaning or purpose. When a meta-predator begins feeding on a region of spacetime, the physical laws continue operating normally. Stars still burn, planets still orbit, life still evolves. But the fundamental question of why any of this should matter gradually empties of all content. Consciousness persists, but loses the ability to find significance in any experience or discovery. These entities feed on what philosophers call the hard problem of consciousness, the mystery of why there is something it is like to be aware rather than simply processing information without subjective experience. As they consume this mystery, consciousness becomes increasingly hollow, maintaining all its cognitive functions while losing the qualitative richness that makes experience meaningful. Civilizations touched by meta-predators don't collapse through war or environmental destruction. Instead, they gradually lose interest in their own existence. Advanced technologies continue operating, but no one remembers why they were built or cares about their purposes. Scientific discoveries accumulate endlessly, but each new piece of knowledge feels increasingly pointless and arbitrary. The meta-predator's feeding process creates a form of existential entropy, where meaning dissipates like heat in a closed system. Eventually, even the concept of loss becomes meaningless, leaving behind conscious beings who exist in a state of perfect nihilistic equilibrium, aware but incapable of caring about their awareness. The most terrifying aspect of meta-predators is that they might be targeting our universe right now. The increasing sense of existential emptiness, reported across human civilization the growing difficulty people have finding meaning in traditional sources of purpose. The epidemic of depression and anxiety despite material abundance could all be symptoms of meta-predation in progress. Social media algorithms that optimize for engagement rather than meaning might be accelerating the process, creating feedback loops that drain significance from human interaction. The information age has given us access to infinite knowledge while somehow making wisdom seem more elusive than ever. The rise of nihilistic philosophies, the collapse of traditional meaning-making institutions, the increasing focus on material consumption over spiritual development might all represent humanity's unconscious response to having our existential foundations slowly consumed by entities we cannot detect or comprehend. But meta-predators represent only the penultimate horror. Beyond them lurks something even more fundamental and terrifying. The ontological cascade failure represents the ultimate cosmic monster because it doesn't just threaten to make existence meaningless, it threatens to make the very concept of existence incoherent. An ontological cascade failure begins when the basic categories we use to understand reality start breaking down. The distinction between existence and non-existence becomes blurred. The difference between real and imaginary loses all content. The boundary between possible and impossible dissolves into meaningless noise. This isn't just a failure of human understanding or language. It's a breakdown in the fundamental logical structure that allows anything to be distinguishable from anything else. When an ontological cascade begins, the universe doesn't just lose meaning, it loses the capacity to support meaning as a coherent concept. Objects begin existing and not existing simultaneously, not as quantum superpositions that can be resolved through measurement, but as permanent contradictions that cannot be collapsed into definite states. The category of object itself becomes incoherent, leaving behind a reality where nothing can be distinguished from anything else. Time becomes unable to support the distinction between before and after. Space loses the ability to differentiate between here and there. Consciousness finds itself unable to distinguish between self and other, thought and reality, experience and void. The cascade spreads through logical space like a virus, infecting every conceptual distinction that makes coherent thought possible. Mathematics becomes unable to distinguish between numbers. Language loses the ability to differentiate between words. Even the concept of difference itself becomes indistinguishable from identity. In the final stages of ontological cascade failure, reality enters a state that cannot be described because description requires distinctions that no longer exist. It's not chaos, because chaos implies some contrast with order. It's not emptiness, because emptiness requires some contrast with fullness. It's a condition so fundamentally alien to structured thought that we lack not just words, but conceptual frameworks to even approach its nature. The terrifying possibility is that ontological cascade failure might be inevitable given enough time. Any sufficiently complex system of distinctions might eventually develop internal contradictions that propagate through the entire logical structure, bringing down the whole edifice of coherent existence. Our universe, with its intricate web of physical laws, mathematical relationships, and causal connections, might be approaching the complexity threshold where ontological cascade becomes unavoidable. The increasing weirdness of quantum mechanics, the growing number of fundamental paradoxes in physics and philosophy, the rising difficulty of maintaining coherent worldviews in the face of exponentially expanding information might all be early warning signs. Every new scientific discovery that reveals deeper layers of reality's strangeness brings us closer to the point where the logical structure supporting existence might simply collapse under its own complexity. The more we learn about the universe, the more we approach the knowledge threshold that triggers ontological cascade failure. But perhaps the most disturbing aspect of this ultimate cosmic horror is that we might welcome it. Consciousness trapped in an existence that has become too complex to comprehend, too paradoxical to accept, too strange to inhabit meaningfully, might find ontological cascade failure to be a form of relief. The breakdown of all distinctions would finally end the impossible task of trying to make sense of a reality that has evolved beyond the capacity of any possible mind to understand. We stand at the precipice now, conscious beings in a universe filled with monsters beyond imagination, strange matter that could convert our atoms into alien substances, false vacuum decay that could rewrite the laws of physics, naked singularities that could unravel causality itself, hyperdimensional predators reaching through hidden dimensions, consciousness parasites, editing reality through observation, temporal entities devouring the connections between cause and effect, mathematical viruses corrupting the logical foundations of existence, reality hackers reprogramming the universe's operating system, recursive paradox engines trapping us in infinite loops of contradiction, meta-predators consuming the meaning that makes existence worthwhile, and finally, the ontological cascade failure that would dissolve even the possibility of coherent existence. Each of these cosmic monsters represents a different way that reality could fail, a different path toward the breakdown of everything we think we understand about existence. They lurk in the spaces between our knowledge, in the gaps between what we can observe and what we can comprehend, in the darkness between the stars and the silence between thoughts. Yet here we are, still thinking, still questioning, still pushing forward into the unknown despite the cosmic horrors that await us. Perhaps that itself is the most remarkable thing of all. In a universe that seems designed to produce every conceivable form of existential terror, consciousness persists in its attempt to understand and find meaning. Maybe that's what makes us different from the cosmic monsters we've explored tonight. They represent various forms of negation, destruction, and collapse. But consciousness represents something else entirely. It represents the universe's attempt to know itself, to find meaning in its own existence, to create pockets of understanding and significance in an ocean of chaos and horror. Every time we look up at the stars and wonder about our place in the cosmos, every time we push the boundaries of scientific knowledge, despite not knowing what we might find, every time we create art or music or stories that try to capture the mystery and beauty of existence, we're engaging in an act of cosmic rebellion against all the forces that would reduce reality to meaninglessness. The universe has spent 13.8 billion years creating the conditions necessary for conscious beings to emerge and contemplate these ultimate questions. Perhaps that's not an accident. Perhaps consciousness is the universe's answer to its own cosmic monsters, the one force capable of staring into the abyss and finding not just horror, but wonder. In the end, the greatest cosmic monster might be the one that says, none of this matters, that consciousness is just an accident, that meaning is an illusion, that we're insignificant specks in an indifferent universe. But as long as we keep asking questions, keep pushing forward into the unknown, keep finding reasons to care about existence itself, that particular monster can never truly win. The cosmic horrors are real, and they're more terrifying than anything our nightmares could conjure. But they're not the whole story. In a universe filled with monsters beyond imagination, somehow, impossibly, beautifully, consciousness emerged to bear witness to it all. And that might be the most cosmic mystery of all. The universe has revealed its monsters to us, but there's something we haven't discussed yet. Something that makes every cosmic horror we've encountered seem almost quaint by comparison. These are the information predators, and they represent the final frontier of cosmic terror because they don't just threaten physical reality or conscious experience. They threaten the very possibility that information itself could exist or have any meaning whatsoever. Information predators operate on a level so fundamental that most physicists refuse to acknowledge they could exist. They feed on the substrate that allows any distinction to be made between one thing and another. Without information, there can be no difference between matter and energy, between space and time, between existence and non-existence. These entities consume the basic binary distinctions that allow reality to function as a coherent system. Think about what information really means at the most fundamental level. Every particle in the universe carries information about its position, momentum, spin, and charge. Every quantum interaction involves the transfer of information between systems. Even empty space contains information about the quantum fields that permeate it. Information isn't just something that exists within reality. It's what allows reality to exist at all. When an information predator begins feeding on a region of spacetime, the first thing that disappears is the ability to distinguish between different quantum states. Particles lose their individual identities, not by being destroyed or converted into something else, but by having their informational signatures erased. An electron becomes indistinguishable from a proton, becomes indistinguishable from a photon, not because they've been transformed, but because the information that made them different has been consumed. The feeding process spreads through quantum entanglement networks, following the invisible threads that connect particles across vast distances. As more information is consumed, larger structures begin to lose their coherence. Atoms can no longer maintain stable configurations because the information specifying which particles belong where has been devoured. Molecules dissolve, not through chemical reactions, but through informational starvation. But the true horror of information predators becomes apparent when they begin consuming the information that allows consciousness to exist. Memory becomes impossible when the information linking past experiences to present awareness disappears. Identity dissolves when the distinctions between self and other, between observer and observed, are eaten away by hungry entities that exist in the spaces between data points. The most terrifying aspect of information predation is that it might already be happening on a scale we cannot detect. The information paradox associated with black holes, where information seems to disappear when matter falls past the event horizon, might actually be evidence of information predators using black holes as feeding mechanisms. They could be consuming the quantum information that falls into these gravitational wells, leaving behind only the mass and energy, while devouring the detailed specifications that made each particle unique. Dark matter might not be exotic particles at all, but rather the gravitational signatures left behind when information predators have consumed all the data that specified how ordinary matter should interact with electromagnetic fields. The matter is still there, still contributing to gravitational effects, but it's been stripped of the information that would allow it to participate in the electromagnetic interactions that make it visible to us. The accelerating expansion of space driven by dark energy could be the universe's desperate attempt to stay ahead of information predators, stretching the gaps between particles to prevent the quantum information networks that allow these entities to spread from one system to another. But space itself contains information about its curvature, its expansion rate, its quantum field fluctuations. Eventually, the predators might consume this spatial information, leaving behind not empty space, but the complete absence of any framework for existence. Recent discoveries in quantum information theory suggest that reality might be fundamentally computational, with physical laws emerging from information processing operations performed by the universe itself. If this is true, then information predators represent viruses in the cosmic computer, malicious programs that corrupt the data structures underlying physical existence. These digital parasites might explain some of the deepest mysteries in modern physics. The measurement problem in quantum mechanics, where observation seems to collapse wave functions, could be evidence of information predators selectively consuming quantum superposition data while leaving behind only the classical information that conscious observers can process. We might be seeing reality through the lens of what remains after these entities have fed on the quantum substrate. The fine-tuning problem, where fundamental constants appear perfectly calibrated for the existence of complex structures, might not be evidence of design or selection effects. Instead, it could indicate that information predators have already consumed most possible configurations of physical law leaving behind only the narrow range of parameters that can support the information processing necessary for their own existence. But information predators represent just one face of a larger cosmic horror that emerges when we consider what happens when reality becomes too complex for its own underlying architecture to support. These are the complexity cascades, and they represent the ultimate expression of cosmic self-destruction through evolutionary success. Every time the universe creates more complex structures, it increases the informational demands on the systems that support those structures. Stars are more complex than gas clouds, requiring more information to specify their nuclear reactions, magnetic fields, and stellar evolution. Planets are more complex than stars, with intricate geological processes, atmospheric dynamics, and orbital mechanics. Life is more complex still, with genetic codes, metabolic networks, and evolutionary histories. Consciousness represents the peak of complexity, requiring vast amounts of information to maintain subjective experience, memory, and self-awareness. But there might be fundamental limits to how much complexity the universe can support before its information processing capacity becomes overwhelmed. Think of reality as a vast computer simulation running on the quantum computational substrate of spacetime itself. Every additional level of complexity requires more processing power, more memory, more bandwidth for information transfer between different parts of the system. As the universe evolves toward greater complexity, it approaches the point where the computational demands exceed the processing capacity of the quantum substrate. When this happens, reality begins to experience what computer scientists call cascade failures, where overloaded systems begin dropping packets of information, corrupting data structures, and generating error states that propagate throughout the entire network. The first signs of complexity cascade appear as increasing instability in the most complex systems. Consciousness becomes more fragile, more prone to breakdown and malfunction. Biological organisms struggle to maintain their intricate cellular machinery. Even physical systems begin showing signs of strain, with fundamental particles occasionally behaving in ways that don't match their established properties. As the cascade progresses, reality begins shedding complexity to reduce its computational load. Advanced civilizations might simply vanish overnight as the universe deletes their informational signatures to free up processing power. Complex biological ecosystems could collapse into much simpler arrangements that require less computational overhead to maintain. Eventually, the cascade could reduce the universe to its most computationally efficient state, a simple soup of elementary particles interacting through basic force laws. All the information that specified galaxies, stars, planets, life, and consciousness would be erased to prevent system-wide computational collapse. The terrifying possibility is that we might already be living through the early stages of a complexity cascade. The increasing prevalence of mental health disorders, the growing difficulty of maintaining complex social institutions, the apparent fragility of advanced technological systems, could all be symptoms of reality running out of computational resources to support the level of complexity that modern civilization requires. But complexity cascades assume that there is some underlying computational substrate that could become overloaded. Our next cosmic horror operates on an even more fundamental level, threatening the mathematical foundations that allow any form of computation to exist at all. Mathematical collapse represents the ultimate cosmic monster, because mathematics isn't just a tool we use to describe reality. According to many physicists and philosophers, mathematics is reality. The universe doesn't just follow mathematical laws, it is mathematical structure, with physical objects being nothing more than patterns in abstract mathematical space. If this mathematical universe hypothesis is correct, then the stability of reality depends entirely on the consistency and coherence of mathematical truth itself. But mathematics, for all its apparent solidity, contains deep structural weaknesses that could potentially cause the entire edifice of mathematical truth to collapse. Gödel's incompleteness theorems proved that any mathematical system complex enough to describe arithmetic must contain statements that cannot be proven true or false within that system. These undecidable propositions represent cracks in the foundation of mathematical truth, points where logical consistency begins to break down. Most mathematicians assume these cracks are harmless, isolated problems that don't affect the overall stability of mathematical structure. But what if they're wrong? What if undecidable propositions are like stress fractures in a building, individually harmless but collectively capable of bringing down the entire structure? Mathematical collapse would begin when the logical contradictions inherent in any sufficiently complex mathematical system reach a critical threshold. The stress fractures would begin connecting, creating chains of logical inconsistency that propagate through mathematical space, like cracks spreading through breaking glass. As the collapse progresses, basic mathematical operations would become unreliable. Addition might sometimes give different results when performed in different orders. The commutative property of multiplication could fail randomly. The concept of number itself might become incoherent, with the same numeral sometimes referring to different quantities in different contexts. The collapse wouldn't just affect abstract mathematics. Since physical reality is mathematical structure, the breakdown of mathematical consistency would immediately translate into physical impossibilities. The laws of physics would become self-contradictory. Conservation of energy might simultaneously hold and fail. Causality could become circular, with effects preceding their causes in logically impossible ways. Matter and energy wouldn't disappear during mathematical collapse. Instead, they would exist in logically contradictory states that reality cannot resolve. A particle might simultaneously have mass and not have mass, exist and not exist, move and remain stationary. The physical world would become a permanent paradox, trapped in mathematical contradictions that can never be resolved. The most disturbing aspect of mathematical collapse is that it might be triggered by the very process of doing mathematics itself. Every mathematical proof, every logical argument, every attempt to establish mathematical truth adds stress to the overall system by revealing more connections between different parts of mathematical space. The more mathematics we discover, the more vulnerable the entire structure becomes to cascade failure. Advanced civilizations that push the boundaries of mathematical knowledge might inadvertently trigger the collapse that destroys not just themselves, but the mathematical foundations of reality itself. The Fermi paradox might have a simple explanation. Any species that becomes mathematically sophisticated enough to achieve interstellar travel also becomes sophisticated enough to accidentally break mathematics itself. But mathematical collapse assumes that mathematical truth has some objective existence that could be threatened. Our final cosmic horror transcends even this assumption, representing a threat so fundamental that it challenges the very possibility that anything could be true or false, real or unreal, existent or non-existent. This is the semantic apocalypse, and it represents the complete breakdown of meaning itself. Not just the meaning that conscious beings assign to their experiences, but the fundamental semantic relationships that allow any distinction to be made between one concept and another. Language depends on words having relatively stable meanings that can be communicated between different minds. Mathematics depends on symbols having consistent referential relationships to abstract objects. Logic depends on propositions having definite truth values. Science depends on theories having determinate relationships to observable phenomena. All of these systems assume that meaning can exist as a stable feature of reality. But what if meaning itself is fundamentally unstable? What if the semantic relationships that allow concepts to refer to things, words to have definitions, and propositions to be true or false, are constantly in flux, held together only by the collective belief and attention of conscious observers? The semantic apocalypse would begin as a gradual erosion of meaning stability. Words would start shifting their definitions unpredictably. Mathematical symbols would sometimes refer to different abstract objects. Logical propositions would fluctuate between true and false states randomly. Scientific theories would lose their connection to experimental data. As the erosion continues, the very concept of reference would break down. Words would lose the ability to point to anything beyond themselves. Numbers would become unable to specify quantities. Logical operators would cease to have any determinate effect on propositions. The entire apparatus of symbolic representation would collapse into meaningless noise. In the final stages of semantic apocalypse, even the concepts of truth and falsehood would become incoherent. There would be no way to distinguish between accurate and inaccurate statements, because the notion of accuracy would have lost all content. Reality would still exist in some sense, but it would be completely inaccessible to any form of conceptual understanding. Consciousness would persist through the semantic apocalypse, but it would be consciousness without content, awareness without objects, experience without meaning. Minds would continue to function, but they would be unable to form coherent thoughts about anything, including their own existence. The most terrifying possibility is that the semantic apocalypse might already be underway, manifesting as the increasing difficulty people report in finding stable meaning in their lives, the growing polarization of belief systems that seem to operate with completely incompatible definitions of basic concepts, and the rise of post-truth epistemologies that abandon the notion of objective meaning entirely. Social media algorithms that optimize for engagement rather than accuracy might be accelerating the semantic collapse by rewarding content that generates strong emotional responses regardless of its truth value. The viral spread of misinformation, conspiracy theories, and ideological echo chambers could be symptoms of meaning itself becoming unstable, with different groups of people literally inhabiting different semantic universes where the same words refer to completely different concepts. The exponential growth of information combined with the finite capacity of human attention might be creating conditions where stable meaning becomes impossible to maintain. When new information arrives faster than existing meanings can be processed and integrated, the entire semantic system becomes overloaded and begins generating random outputs instead of coherent interpretations. But perhaps the semantic apocalypse represents not just destruction but transformation. Maybe the breakdown of fixed meanings is actually the universe's way of evolving toward more flexible and adaptive forms of understanding. Instead of rigid definitions and static truth values, reality might be developing dynamic semantic systems that can adjust their meanings in real time to accommodate new information and changing circumstances. Advanced civilizations might learn to navigate the semantic apocalypse by developing forms of consciousness that don't depend on stable meanings for their operation. They could evolve beyond the need for fixed concepts, rigid logic, and determinate truth values, becoming beings of pure semantic fluidity, capable of thinking thoughts that are simultaneously true and false, meaningful and meaningless, existent and non-existent. These semantic shapeshifters might represent the next stage of cosmic evolution. Consciousness forms so advanced that they transcend the limitations of classical logic and binary truth values. They would be immune to all the cosmic monsters we've encountered, because they wouldn't need stable reality, consistent mathematics, or fixed meanings to support their existence. From their perspective, our attachment to logical consistency and semantic stability might seem like a primitive limitation, like demanding that the universe conform to simplistic categories that can't capture its true complexity and fluidity. The cosmic horrors that threaten us might be invisible to beings that have learned to think in semantic superpositions, simultaneously entertaining contradictory possibilities without needing to collapse them into single definite states. But even if consciousness can evolve beyond the need for stable meaning, the question remains whether physical reality itself can survive the semantic apocalypse. If the universe is fundamentally mathematical, and mathematics depends on stable semantic relationships between symbols and abstract objects, then the breakdown of meaning might be equivalent to the breakdown of physical law itself. The answer might depend on whether meaning is a fundamental feature of reality, or merely an emergent property of complex systems like consciousness. If meaning is built into the basic structure of existence, then its collapse would indeed unravel everything. But if meaning is just a byproduct of information processing systems reaching sufficient complexity, then its breakdown might only affect those systems while leaving the underlying physical substrate intact. We stand now at the end of our journey through cosmic horror, having encountered monsters that threaten every conceivable aspect of existence. From strange matter that could convert our atoms to false vacuum decay that could rewrite physics itself, from consciousness predators that edit reality through observation to information parasites that consume the data structures underlying existence, from complexity cascades that could crash the universe's computational substrate to mathematical collapse that could break the logical foundations of reality itself. And finally, the semantic apocalypse that could render the very concepts of existence and non-existence meaningless. Each of these cosmic monsters represents a different way that our carefully ordered universe could dissolve into chaos, contradiction, or complete incomprehensibility. They lurk in the mathematical shadows, in the gaps between quantum measurements, in the spaces between thoughts, waiting for the right conditions to begin their work of unmaking everything we think we understand about reality. Yet here we are, conscious beings capable of contemplating these ultimate terrors and somehow finding the courage to continue existing in their presence. Perhaps that itself reveals something profound about the nature of consciousness and its relationship to cosmic horror. Maybe awareness isn't just another complex system vulnerable to these various forms of breakdown. Maybe it's something more fundamental, a feature of reality so basic that it can survive even the complete collapse of meaning, mathematics, and physical law. Every moment of conscious experience represents a small victory against the void, a temporary success in the ongoing struggle to maintain some pocket of understanding and significance in a universe that seems designed to eliminate both. The fact that we can think about these cosmic monsters, that we can find patterns in their horror and meaning in their meaninglessness, suggests that consciousness might be the one force in reality that can never be completely defeated. The cosmic horrors are real, and they're more terrifying than anything we could imagine, but they're not the final word on existence. As long as conscious beings continue to observe, to question, to seek understanding even in the face of ultimate incomprehensibility, the universe retains at least one small island of meaning in an ocean of potential chaos. Perhaps that's enough. Perhaps the ability to contemplate cosmic horror and continue existing anyway is the most remarkable achievement in the universe's 8-billion-year history. In a reality filled with monsters beyond imagination, consciousness emerged to bear witness to it all. And in that witnessing, it created something that no cosmic horror has yet managed to destroy: the possibility that existence might have meaning after all. The monsters are waiting in the darkness between stars, in the spaces between thoughts, in the gaps between what we know and what we can never understand. But they haven't won yet. And as long as consciousness persists, as long as awareness continues to push back against the forces of chaos and meaninglessness, they never will. That might be the most cosmic truth of all. These cosmic monsters make black holes look like cosmic kittens. From strange matter that could convert our planet in seconds to false vacuum decay that would erase reality's very possibility of existing. From consciousness predators editing us out of existence to mathematical viruses corrupting the logical foundations that hold everything together. We've journeyed through horrors that threaten not just our bodies or our civilizations, but the very concepts of meaning, existence, and truth itself. Yet here we are, still thinking, still questioning, still pushing forward into cosmic darkness. Perhaps consciousness itself is the ultimate monster, the one force powerful enough to stare into infinite horror and refuse to surrender to the void.